Hello everyone, this is Unit 0, Fundamentals of Chemistry, Section 1, Chemical Calculations. So far we've talked about measurement and how to make sure that we're measuring to the correct precision. We're estimating 1 decimal point past the smallest increment. We're making sure that we are being as accurate and precise as possible, including using the best glassware. So we've talked about that, but we haven't really talked about what to do once we actually get to the calculations. How do we know how many decimal places to put in the calculations? Why is that important? And also just how to do some of these chemical calculations. So we're going to get into that into this section. So make sure that you have the Unit 0, Section 1, Fundamentals of Chemistry guided notes, and those have some practice problems within them that you're going to do while you watch the video. Alright, so we're going to be talking about dimensional analysis, which is really just a fancy way of saying we're going to convert from one unit to another unit. So that would be inches to feet, meters to kilometers, whatever it is. We're going to convert from one unit to another unit. And in order to do that, we need to have something called a conversion factor, which are fractions or ratios that show a relationship between two units. So we've got two units that we're going to show, and we need some sort of fraction or ratio in order to relate the two units and to do something with them. So for an example, when converting between inches and feet, you need to know that 1 foot equals 12 inches. You need to form a relationship between the two so that you can actually convert between it. We show our conversion factors using a fraction usually, and it doesn't really matter which one's on top if we're just showing the individual conversion factor. So a conversion factor could be 1 foot is equal to 12 inches, or it could be 12 inches is equal to 1 foot. It doesn't matter which one is on top at this point. All that we need to make sure is that each of these is a true statement. I can't have a conversion factor of 1 foot equals 36 inches because that's not true. That's not a valid relationship. Alright, so at this point we have the actual setup for your conversions, for your dimensional analysis. And I want this set up every single time you do a dimensional analysis problem. I don't care if it's a simple how many feet are in 12 inches or how many feet are in 24 inches. I want it set up in this format, which is what I call a T-chart. And you start out just by drawing a middle line down the center right here. And then every time you write a conversion factor, you can just draw a line between it like so until you are finished. But once you get to this T-chart or this setup for this, what you're going to do is you need to actually figure out how to plug it into your calculator. So the important things here to know are that you really need to be aware of order of operations here, because if you just plug it all into your calculator, your order of operations is going to screw up and it will mess up your final answer. So you might get all of the points on the test for setting it up correctly, and then you messed up on putting it into your calculator and you'll lose a bunch of points there and get all grumpy about it. So we are just really multiplying fractions. This is a fraction. This is a fraction. We are just multiplying the numerators, multiplying the denominators, and dividing the two. So in your actual calculator, you're going to, let me actually erase all of this junk that I have. All right, so in your calculator, we need to multiply the numerators. So the way you're going to do that is you're going to put a parentheses around all of these top numbers and multiply each one. A times B times C, and that all needs to be in one big parentheses. And then you're going to divide it by, again, in parentheses, C times E. So remember, when you multiply fractions, you're multiplying all the way across the top, multiplying all the way across the bottom, and then dividing. If this is like too much for your life, then what you can do is you can find the answer to each one individually. So find the answer to this guy. Find the answer to this guy, and then just divide the two numbers. You don't have to do it all in one step. You can just do it separately in your calculator. It's not that big of a deal. So at this point, what I want you to do is I want you to flip to the practice problems, and I want you to try and answer the conversion problems on the conversion problems number 1 through 3. And those are really just multiplying fraction problems to make sure that you're good with setting it up and putting it into your calculator. You're just putting it into your calculator and going. So if you're not getting the answer correctly, then it's a calculator error. So now we're going to get into how to actually set up one of these problems. So I might pose the question, how many seconds are there in 2.3 days? So here's where you probably want to color code. So you are going to start off with whatever number they give you. So they give you 2.3 days as your starting number. That is what you are starting with in your actual calculation. Okay, whatever number they give you, that's what you're putting in first. Now you have to figure out, how can I relate days to seconds? And it might be multiple steps, and that's totally fine. If you can't get to it in one step, then you'll just have multiple conversion factors to go through. So I don't memorize days to seconds. I don't have that in my brain, but I do know that in one day there is 24 hours. So this guy here is a conversion factor. One day is 24 hours. Remember, that has to be a true statement. Now, in this case, you might be wondering, well, why does days go on bottom? So what we have going on is we need whatever unit was here, we need it to be on bottom. Because remember, if we're talking about canceling things, the numerator and the denominator will cancel. So this guy cancels out this guy, and our current unit is hours. Now, to get rid of hours, because our final answer needs to be in seconds, we are going to compare hours to minutes. So I know that in 1 hour, there is 60 minutes. And again, we want hours to cancel, so we put hours on bottom. Now our answer is in minutes. In 1 minute, there's 60 seconds. So minutes on bottom and seconds on top. I know when I finished when I get to whatever I was looking for. So the question asked, how many seconds are there in 2.3 days? And my final answer is in seconds. It is the only unit that has not been canceled out. So if you're ever getting through a long dimensional analysis problem and you're like, when is this ever going to end? Reread the question and make sure you didn't just go in some random direction. Stop whenever you get to the unit you are looking for. So this is just a set of metric conversions that you might need to use. It's conversions that are going between metric and imperial. So if you ever need these, which you might in the practice problems or in some of the other problems throughout the PowerPoint, here's a bunch of them just in case you're interested or if you need them. So here's another dimensional analysis practice. So this one asks to calculate the number of millimeters. So again, I'm going to highlight what I'm looking for. I'm looking for millimeters in 10.2 gallons of gasoline. So again, you start with whatever number you are given. So the only number I was given in the question was 10.2 gallons. So that's what I'm starting with here. So you definitely need to go back and look at your unit conversions on the previous slide. So if you need to, and so that you can see where these numbers came from, go ahead. But at this point, we can see that we need gallons on bottom for this conversion factor. We need gallons on bottom so that gallons will cancel. So gallons cancel, and our unit is quarts. Then we can convert between quarts and liters because, again, we're trying to get to milliliters, so eventually we need to convert between the imperial system and the metric system. And the way to do that is relate quarts to liters. Quarts has to be on bottom so it can cancel. Now we are in liters. One conversion that you will need to memorize, and we'll get to which ones you need to memorize in a little bit, is that there are 1,000 milliliters in 1 liter. 1 liter cancels, 1,000 on top. So remember, when you plug this in your calculator, actually go through and plug it into your calculator right now so that you can double check that you are doing it correctly. So you multiply all the way across the top, multiply all the way across the bottom, and divide the numerator and the denominator, and you should get 38,760 milliliters. At this point, I want you guys to flip to the practice problem section, and you should be able to complete. You're going to skip questions 4, 5, 6, and 7. We'll get to those in a minute. And you're going to complete questions 8, 9, 10, and 11. Honestly, you could actually go ahead and do 12, 13, and 14 as well. We will get to question 15 in a little bit. So pause, work on questions 8 through 15, or 8 through 14, and we'll get back to it. So scientific notation versus standard notation. Standard notation is really just whatever the actual number is. But a lot of times in chemistry or in science in general, we work with very, very, very large numbers or very, very, very small numbers. Specifically very small numbers when we're talking about sizes in chemistry, like atoms are really tiny. Or large numbers when we're talking about quantities of atoms. There's billions and trillions and gazillions of atoms of carbon and different things. So we're going to be working with very large or very small numbers, and I don't want to be writing a million zeros after a number, so we come up with an easier way to write very large and very small numbers. And the way to do that is with scientific notation. So there's two rules. If it is a large number, if it's greater than 10, if it's greater than 9 actually, then what you're going to do is you are going to move the decimal place to the left, and you are going to make the exponent a positive number. So here's an example. I'll go ahead and do this 54 one here and write out how we got that. So the question was 54 and converting that to scientific notation. So I moved the decimal from its understood place here, and I need to move it until we have one non-zero number in front of the decimal place. So now the scientific notation version would be 5.4 times 10 to the first power. Our exponent is positive because it is a large number. For the next one, 70,789, I'm going to move the decimal place 1, 2, 3, 4 times, and there we get 7.0789 times 10 to the fourth. Again, positive exponent means positive number. Now, if we were going in the opposite way, if I was going to be doing a very small number, then you would move the decimal to the right, and your exponent would be negative. So that 0.0898, we need to move the decimal place 2 times. Remember, you need one number in front of the decimal, and we get 8.9 times 10 to the negative 2. Again, the exponent is negative because we had a small number. For the standard notation, you're just going to undo what we just did. So 2.44 times 10 to the 5th. I'm moving, this is a large number because it's got a positive 5, and I have to move my decimal place 5 times. So 1, 2, 3, 4, 5. That means I need to add 3 zeros. So that becomes 244,000, and then I'm adding 3 zeros at the end. Okay, for the next one, we'll do the 7.053 times 10 to the negative 2. I'm moving my decimal the other direction because it's a negative exponent, meaning this is a small number, 1, 2. So we end up with 0.07053. So now you should be able to complete questions 4, 5, 6, and 7. So you have everything done except for the last question in the practice problems. All right, so here's an example where we need to multiply and divide scientific notation, and the best thing I can tell you here is to use parentheses. So in your calculator, you have a button that says EE on it, let me move this so you can see. The button is capital E, and that means times 10 to the whatever. Okay, so when you are putting these numbers in, so if I have like 2.4 times 10 to the second, and I want to put that into my calculator, I'm going to put in my calculator 2.4, and then the EE button, you have to click second first, and then do EE. So in your calculator, it's going to look like this, and your exponent is 2. But don't on your paper ever write EE, but just so you know, that's where the button is. If you need me to show you, I'll show it to you. But I recommend always using EE instead of typing out times 10, because it can get kind of confusing when you do that. And my second recommendation, just to help make sure that the scientific notation doesn't get split up for orders of operations, is always just to put it in parentheses. I would even put that one in parentheses as well. So now that you know how to do that, you can go ahead and complete the last practice problem before moving on. So these are some of the common metric system conversions that we're going to be using. Everything highlighted in yellow is something that you need to memorize. So they will not be provided for you on a test, but you will need to be able to convert between them. So I highly, highly, highly recommend using flashcards for this, because you will need to know the conversion factors in order to calculate. Because we'll often ask you to go from meters to kilometers or from milliliters to liters, things like that. So anything in yellow you need to highlight, or anything in yellow you need to memorize. For general chemistry, you do not need to have nano and or mega. Okay, for honors chemistry, you need all of that. All right, so if I'm doing a metric conversion, here's a couple of really important tips. You always, always, always need to go through your base unit. Always. So your base unit would be meters or grams or liters. That would be your base unit. Your other units are just the conversions in between. So for question number 1, convert 430 centimeters. So again, that's the number we're given. Why are we not highlighting? There we go. That's the number we're given. So that's the number I need to start with here. I'm going to meters, so my answer needs to end in meters. Thankfully, there's a direct relationship between centimeters and meters, and I've got the conversion factor memorized because it was one of the highlighted ones. And I know that 1 meter is equal to 100 centimeters. So I put centimeters on bottom so it cancels, and I know that I can multiply across the top, divide by the bottom, and get 4.3 meters. For problem number 2, it's not going to be a single step problem because problem number 2 is starting with 15 kilograms, but we're not going to the base unit as our answer. Our base unit would be grams, but we actually want to go to milligrams. So this is going to be at least a 2-step conversion. So I'm starting with kilograms because that's the number they gave me. I know I need to go to the base unit because that's the rule. Always go to the base unit. That way you don't have to memorize any other crazy conversions. You just have to memorize those ones. So we've got 1 kilogram goes on bottom. Kilogram, cancel, cancel, and now our unit is grams, our base unit. But my answer shouldn't be in grams, it needs to be in milligrams. So now I need to convert between grams and milligrams. Again, grams cancels, so we want to put grams on bottom. And our final answer was asked to be milligrams. Oops, that's not a highlighter. That's okay. Here we go, highlighter. Okay, so now I know that I'm done because everything else is canceled out. Boom, boom, boom. So this final answer, typically I would prefer this written, since it is such a big number, I would prefer this written in scientific notation. So it'd be 1.5 times 10 to the 7th power milligrams. So hopefully you guys feel really good about this. If you don't, please make sure you come in and get help. It'll probably just take a few minutes, but if you wait and wait and wait, then it's going to take a much longer time. So come in and get help right away if you're struggling.